For the given function, let's look at how we can find the inverse function. The first thing that we want to check is that the given function is a one-to-one function, meaning that the inverse does exist. So if we think about our function f of x equals 1 over x plus 5, this is related to our toolkit function that we called the reciprocal function. So this was the function, it's undefined for x equals 0, and it had two separate pieces on its graph. By having a plus 5 inside of the function, it has shifted our graph of our toolkit function to the left 5 units. So if you can picture your toolkit function for the reciprocal function, now imagine shifting everything to the left by 5 units. So we're still going to have these two separate pieces on our graph. It's just that everything has been shifted over. The way that we check that a function is a one-to-one function is using our horizontal line test. And no matter where we draw a horizontal line on this graph, it would only intersect our graph in one place. So you can imagine anywhere you draw it in, it would have just one single intersection point. So this is a one-to-one function. Because it's one-to-one, it means that an inverse does exist. So the strategy that we're going to use to find our inverse function is what we call our switch and solve strategy. So the idea of switch and solve is that we have our original function. I'm going to write it as y equals 1 over x plus 5. The relationship between a function and its inverse is that every single ordered pair, the x and the y, has been switched. So we can do that for every single point on the graph at once by switching them in the function. So I'm going to rewrite this as x equals 1 over y plus 5. So that's the switch part of switch and solve. What I want to do now is actually solve this equation for y. So I'm going to start by eliminating the fraction, multiplying both sides by y plus 5. So on the right hand side, that cancels out the fraction. So we're left with x times y plus 5 is equal to 1. So keep in mind we're trying to solve for y. So we have two options at this point. We could distribute our x, or we could go ahead and divide both sides by x since it's x times y plus 5. So I'm going to go ahead and divide both sides by x. That leaves me with y plus 5 equals 1 over x, and then I'm going to subtract 5 as well. So I have y equals 1 over x minus 5. Just for comparison, if you had distributed, you would have had xy plus 5x is equal to 1. So subtracting the 5x, you would have xy equals 1 minus 5x, and then you would divide everything by x. You'd get y equals 1 minus 5x all over x. If you compare those two equations, they look different, but they are equal or equivalent to one another. Because if you think about dividing each of those terms in the numerator by x, 1 divided by x would give us 1 over x. 5x divided by x would give us 5. So these are two different ways of writing the same function. So for our final answer, we'll go ahead and put it into our inverse notation. Our inverse notation uses the -1 to show that this is the inverse of that original given function f. So our inverse function is 1 over x minus 5. So this function is related to the original function in that every single ordered pair, the x and the y, have been switched. So this has taken the entire domain and the entire range and switched those two.